we are kind of where the Chinese were 25 years back. So one American company went bankrupt, one Japanese company is...
Because of rise of this Chinese company.
Yes. China is massively investing in... So our question was, how are you going to compete?
You're trying to discourage people from starting a chip design company?
No. So I recently met a team of people who think that what can globally be done with $250 million will be done at 100. This is the ecosystem disruption that India can take advantage of. So the mission is to create a semiconductor ecosystem in India. We've come a long way, but at the same time, we need to stay at it for 20 years. We need the government funding to keep flowing. A number of large Indian groups, when they were approached by the government, they had zero trust in the government. So we need to build our credibility. I remember one very embarrassing interaction. I will not mention the company's name. So they had a partner. That guy gave us a lecture for 15 minutes, effectively saying beggars can't be choosers. The foreign company was taking 5% stake in this. And that company was not putting its own money. So it was just saying that, I will share technology and in return I'll get 5% stake. My thing was, you can walk away anytime. Where is your skin in the game?
Neelkanth, welcome back to SparX.
Yeah.
I think you continue to be very much in demand. I think we feel like we need to come back to you every 6 months, perhaps sooner. The pace of progress in the world, seems to be accelerating. I'm just amazed. I'm really struggling to keep up. So talking to you is a good way to really know what's happening in the world, what's happening in India, how should we be navigating. And I think you are in the middle of a lot of things. Today, I want to focus on, you have a specific role with the Semiconductor Mission, which I think finally making a lot of strides in last 1 or 2 years from everything I read in the news. But it also seems like overall tech is becoming very, very important for as far as policy making, governance is concerned. So we'll talk about probably both aspects today, starting with semiconductor. So let's start with your interest in semiconductor. I think one of the podcasts I remember talking to you in your early days of your career, you spent time working as a semiconductor analyst.
Yes. So that was 2003 onwards. Yeah. And so I was hired to cover IT services, but my boss was struggling with it. Not struggling, but he wanted help in coverage of semiconductor foundries in Taiwan. So within a few months, I was transitioned. So I covered Taiwanese foundries, memory, as a strategist, a tech strategist. I went to Taiwan and I covered chip design companies myself. I was the part of the team that took SMIC public, the biggest semiconductor company of China. And so it was, and it is such a fascinating field that even though I had not, actively covered it for 17, 18 years after that, I was still keeping track of it as to how the node transitions are happening. Yeah. What the big companies are doing. It's been a fascinating program.
And look, our world is today run on tech, and pretty much entire tech is run on semiconductors. I'm pretty sure this mic that we are using, इसके अंदर भी chip लगी हुई कोई, most likely China में बनी हुई data कहाँ जा रहा है, किसी को नहीं पता. But the way you are laughing, it seems like you know more than what you want to.
I don't think it was like that.
But the point is, there is not a single electronics gadget or device जिसमें semiconductor use नहीं होता है. जहाँ तक मुझे पता है, आज की तारीख में अभी तक तो नहीं बनता इंडिया में, and Semiconductor Mission is trying to change that.
Yes.
Again, it has had, I think, it has had a little checkered past. I think we've been trying to do it for a while, but looks like पिछले 4-5 साल में थोड़ा momentum आना शुरू हुआ है. तो just what is the thought process behind Semiconductor Mission? क्या चल रहा है और स्पेशली पिछले कुछ साल में क्या हो रहा है, सो वी कैन फील ऑप्टिमिस्टिक कि 5 साल बाद ये पॉडकास्ट इंडिया के चिप के साथ शूट करेंगे.
नहीं, वो हो सकता है. So that is very much possible. I must say that when our Mohali facility in India was set up, it was I would say even ahead of course ahead of China at that time, but in the early 80s it was even ahead of Taiwan. And then we let the ball drop. We didn't invest.
India was ahead of Taiwan in 80s.
because we've had that the laboratory in Mohali for a while.
ये स्टोरी में कई बार मैं सुन चुका हूँ कि 80s में ना इवन TIFR इन सुपर कंप्यूटिंग मिनी कंप्यूटर में कुछ आई थिंक 70s में लाइक so much advantage in 70s, 80s which are fitted away.
HCL computers, so on hardware, PC manufacturing as well. I think we had a fairly decent manufacturing setup.
2 generations lost out. जो भी हुआ मतलब जिस वजह से हुआ जैसे हुआ, but
exactly. But anyway, so periodically I think people did wake up and say, oh, we need to do semis. So I think 2006-07 there was an attempt. 2016, 15-16 also I think there was an attempt. But both these times, and that's why the credibility also for India had gone down. India is not able to execute on the plans it makes. And so when this third attempt was made, so December 21, India Semiconductor Mission was formed.
This time it was backed right from the top. See, the Prime Minister himself is personally involved now. So he has approved a $10 billion budget, and to tell the country and the bureaucracy how deep his conviction is, he has inaugurated every single Semicon India conference. He also meets the heads of global semiconductor firms regularly. Around Semicon India, there is a group CEO meeting. One mentioned that in September 2025, the PM was making notes as he spoke, and then promised that all the issues that were mentioned would be addressed well before they met next. Semiconductors are now part of the diplomatic agenda on summit meetings, say with the leaders of the US, Japan and Korea, which have the technology that we need. You have seen pictures of the PM and Intel CEO in Bhutan recently, after Intel and Tata Electronics signed an MOU. He has also put the right people on the job. So the Minister Ashwini Vaishnav not only understands technology, he is also from IT Kanpur, but understands business, has been an administrator and also a policy maker. As you know, he turned around railways capex. You can see his imprint not only on the structure of the policies, like the significant capital subsidies, but also the decision-making process. Foreign firms, as well as the Indian applicants, now get the comfort, because he meets them personally, that there is someone who understands what their needs are. Agencies first help ISM and the ministry vet the detailed proposals. Then external technology and financial experts like me evaluate the applicant's capabilities in detail. There are multiple rounds of deliberations, and applicants are asked to shore up weak parts of their plans, like bolstering the team, say you need more equity capital, get a better partner, and things like that. Then this goes for cabinet approval. If an approved project is getting stuck because the local bureaucracy doesn't understand the importance or are behaving generally how they do with projects, he then goes in and understands how to address the bottlenecks. In fact, in the early years, there was another minister, Rajiv Chandrasekhar, who has himself worked in Intel and can talk about assembly language coding, for example, who also helped shape the policies and processes, and more importantly, build a conviction among global technology firms that India is serious and understands what it wants to do.
The formation of the mission itself was a very important step forward. So the folks at the Ministry of Electronics, I think they realized that, in the bureaucrats are, transferred very frequently. So they are excellent at what you and I will relate to in operating system context switching. So they transition from one role to another very fast. But the systemic memory, which tends to be kept in files, on sophisticated things, that is not enough. So you need a permanent body, which will be the repository of information. So December 21, ISM was formed. Around, I think, March, April, if I remember right, they constituted an advisory board. When you see the advisory board, you realize that there's so many legends in the world of Indian origin, who, one, are not only, at the cutting edge of technology, but also are very willing to give back. So global leaders across firms. And so that body was formed. The government allocated at that time $10 billion, so 76,000 crores. Initially, there was a capex subsidy planned that for advanced semiconductors it would be 40%, for slightly less advanced it would be 30%. But in the first meeting itself, I think all of us agreed that, look, right now we have nothing. And making it too complex on, bringing this, bringing that. So let's keep it very simple. Let's increase it, 50% capex subsidy. On top of this, the state governments have topped up. So some states offer 20%, some states offer 30%. And therefore, by putting in 20-30% of the capex, you get to own a whole fab. So given the large resistance, a huge resistance to setting up a facility, remember that these are very capital intensive, large, complex projects.
Give a sense of capital, like to good fab is what, few $1 billion more?
Depends on which node you're talking about. So just like, in a steel plant, there was a time when you could have, 200, 500 cubic meter furnaces. But today, if you have to be viable, you have to have a 4,000, 5,000 cubic meter furnace. Now, a 5,000 cubic meter furnace, if it runs through the year, will produce 4.5 million tons of steel. In the same way, for a wafer fab, a 12-inch wafer fab, so as you know, silicon wafers are of 8-inch or 12-inch. So 12-inch started about 20-25 years back. For it to be viable, you need to have at least a 40-50,000 wafers per month fab. If you are trying to do 28 nanometers or 40 nanometers, so that range, it can cost anywhere between $5 to $7 billion. If you are trying to do a 2 nanometer fab or a 3 nanometer fab, it could be $20 billion.
And just to put in perspective, today, state of the art in the world is 2 or 3 nanometers.
Yes.
And right now in India, what we are attempting in the 28 nanometer.
Yeah, so we are first attempting 40 nanometers, which is 2028.
Okay.
The plan is to get 28 nanometers by 2030.
Understood. And these 40 nanometer will cost $4 or $5 billion, and 70-80% of that is because of Semiconductor Mission subsidies by the state. So in some ways, the cost of entry for people who put in capital has been reduced dramatically.
So what tends to happen? See, this is, and again, I must be honest that initially, because I was still thinking like an analyst, I was not wholly supportive of this whole exercise. In semiconductors, the value chain is very, very, very long. It's a very large collaborative ecosystem. So you can't do anything on your own. So the complete Aatmanirbharta is impossible, and we can discuss that as we go along. So there are chip design companies. These are called the fabless companies. They don't have a fab, semiconductor fab. Then there are the wafer fabs. Then there are the packaging and testing companies. What you do is you get your wafer fab at nanometer level. But when you are putting them on motherboards, obviously those are very fragile, require very high levels of clean air and all that. And of course, then also they dissipate heat. So you need packaging, which brings it to micron level. And so that you can put it on like a...
Packaging is putting components together in a functioning chip.
Yeah, so you can do that. So there are packages which incorporate multiple chips, but mostly it is encapsulating that piece of silicon into a ceramic or a plastic or a metal packaging.
Sure.
And it's almost like, those millipede type, centipede type things that come out. So those are the wires, and they are micron level or millimeter level. So that's packaging. Wafer fabrication and packaging are together about, depends on chip to chip, but could be 30 to 40% of the, while in the NVIDIA Blackwell chips, NVIDIA makes 80% margin. So the packaging and testing is only about 20%. But, and conversely, if it's a commoditized chip, then the fabless company makes very little money, mostly it is manufactured. Even in the manufacturing, the value add is split between the equipment companies, because the sophistication and the complexity is often in the equipment company itself. So for example, this 2 nanometer, very famously, the Dutch company ASML, they are the only ones who can make the lithography, using that kind of lens. But if you just think through it, so if you are generating ultraviolet light at 2 nanometers, it tends to get absorbed everywhere. And therefore, the mirrors you use to focus it are also manufactured only by 1 or 2 companies anywhere. The lens that can focus that is grown as a single crystal over months, and it also can be done only by Zeiss or one of these companies. So a lot of the value add is actually in the equipment, or even like testing. There are just 2 companies, Teradyne and Advantest, which control 90% of the testing equipment market. So as you can imagine, the manufacturer doesn't have too much bargaining power, and it is one of the characteristics of a system where you add a lot of capacity in bulk, but your demand goes up steadily, is that there are vicious cycles. So there will be bull markets, bear markets, so inventory up cycles, down cycles. And through a cycle, very few companies cover their cost of capital.
When we look from Semiconductor Mission, is the objective is to have all these companies or mostly fabs, the fabless companies, fabs, packaging companies, testing companies?
Awesome. So the mission is to create a semiconductor ecosystem in India.
Okay, so all of these type of companies.
So the 76,000 crore project, the budget that I'm talking about is for wafer fabs and display fabs and packaging plants. There is a separate design-linked incentive scheme to have chip design. We'll come to that.
Sure.
But to finish that argument, because this is a viciously cyclical industry and returns for manufacturers are actually very low. So in the last several decades, there are only 3 companies that have actually covered their cost of capital, meaning that if it is say 10-12% globally. So Samsung and TSMC, they used to be Intel, but now Intel is also struggling. So as an analyst, my first response when not that they were asking me, but when I heard about this, was that why are we wasting money? Right? This is never financially viable. And then I was told that, look, you're thinking like a financial analyst. You think about it from the country's perspective. Do we need a semiconductor ecosystem? Yes. Then how do we build one? So we have to get people through the door. That convinced me, and I think that's the strategy. From there, to actually get large companies to start producing in India. So one of the things I realized was that there are so many people of Indian origin who work in some of the most advanced plants, like, so whether it is Applied Materials or Novellus or even ASML or TSMC or, you name it, right? Everywhere, Micron, full of Indians. Or Indian origin, and many of them wanting to come back. The problem was that there was nothing to bring together the capital formation that was necessary for that one facility where people would start coming back. Now the challenge is that you needed this capital, which was of course a necessary condition, but you also needed someone who had the technology, because it is kind of like an apprenticeship problem that an Indian company cannot just wake up and start doing 40 nanometers looks, it's so 20 years behind the curve. Boss, it's 40 nanometers. I mean, so we're talking about really precision manufacturing. When I started covering semiconductors, the transition was from 130 nanometers to 90 nanometers. And even that was cutting edge. There were so many problems with that. So you need a foreign partner who has the technology, who has the experience of how to manufacture chips.
Right.
But at the same time, most foreign companies will struggle to work in an Indian environment. I mean, for obvious reasons, right? So while the central government may be convinced and the state government is obviously convinced and they're giving the capex, but the local government may not even know what this is about. Like, for example, what is happening now is that some of the plants that are coming up, if they're importing equipment, the customs guys don't know how to classify the equipment because they've never seen that equipment. So there is a learning curve across, and so it is easier for a domestic firm to handle the local bureaucracy about, managing the land, the permissions and this and that. So you have to do a lot of matchmaking. Now, in the first couple of months, I must tell you, it was absolutely depressing because some of the projects that were coming in, and remember, this is like what you all do in say angel investing, that a bunch of entrepreneurs come with a presentation and you say, oh, you know what, okay, fine, take this money and build a business. This was like that because there's nothing on the ground beyond a presentation, and some of these people didn't even have a team. I remember one very embarrassing interaction. I will not mention the company's name, the foreign company's name. So they had a partner, a foreign partner, and I was uncomfortable because that company was the foreign company was taking 5% stake in this. The source of capital for this company wasn't very clear to me. And that company was not putting its own money. So it was just saying that, I will share technology and in return I'll get 5% stake. So my thing was, you can walk away anytime. Where is your skin in the game? And then that guy gave us a lecture for 15 minutes that, effectively saying beggars can't be choosers. So it was really embarrassing that you're throwing so much money on the table, yet you're not getting good people through the door. So things really started turning on two fronts. The first was that Micron came in. So I remember I was taking my kid to the dentist in the evening, and when we heard it was Micron, I said, look, we can't wait for the right time before they change their mind. Let's get them through the door.
Micron is an American company?
Micron is an American company. It's a memory company. So memory is, again, so you will see that in all of semiconductors, there are 50 to 70 blocks of expertise. So for example, the software in which you design chips is called EDA, Electronic Design Automation. And there are only 3 companies effectively that run the business. When you are talking about, say, lithography tools, there used to be 3. Now, effectively, there are 2. Similarly, in memory, there are only 3 companies effectively. I mean, there are more, but large amounts of market share are with just Samsung, SK Hynix, and Micron. So, Micron was exploring how to do a packaging plant.
Okay.
So it is less capital intensive. These are smaller plants, so about $2 to $3 billion, because they're setting up
packaging plant for memory chips in case of Micron.
Okay. Memory chips. So another thing which is very interesting is that memory chips, as you would remember, you just have to store. So it's like creating a grid, and so it's a reasonably simple design, and therefore they're always ahead in terms of node transition.
Okay.
So memory 2 nanometer would have happened way before logic 2 nanometer, because logic chips are obviously complicated.
Yeah.
So then fabbing it is complicated. Designing it is complicated as well. So memory is always a bit ahead. And of course, there are new types of memory requirements. Like this in AI servers, now you need high bandwidth memory. So there are different types of packaging.
So today the state of the art for memory is also 2 nanometers?
I think they've gone 1 nanometer. So they've gone below that as well. But that's on the wafer fab. Sure. What Micron is doing in India is packaging.
Sure.
So when that packaging plant came, we were so excited that this was because see the problem for approving some of these plants is that it is very exciting and very important for the country to do it. The challenge is that you are approving grants of several $100 million, in some cases $1 billion, based on nothing but a PowerPoint presentation.
Yeah.
You have to make sure that, and it's going to be a 3 to 5 year setup journey.
Yeah.
The team has to have the ability to deliver on it. You also have to be sure there is no gold plating. And remember that no one has ever done any semiconductors in India.
Yeah.
So you don't even have any benchmarks. So like clean room, I'll tell you a very, very interesting, it's a fascinating story of how all the risks we know, all the opportunities we are not aware of. So for example, clean rooms.
Yeah.
So when you're manufacturing semiconductors, obviously you're talking about nanometers. So even a dust particle falling will spoil the chip.
Yeah.
Just so that, every time I think about this, I get so excited. So the ingots, the silicon ingots that are used for semiconductors have 10 nines purity. So 99.9999 whatever, 10. So 10 nines purity. Because even one atom, because you're talking about, stitching together atoms.
Yeah.
And so the clean room is like, class 10, like, in 1 cubic meter, you need 10 particles or class 1 or whatever. I don't know if class 1 exists or not, but so obviously, but if you're doing packaging, you can run with class 1000 or class 10,000.
Sure.
Now, it is very expensive because you have to create large rooms where in some of the most advanced clean rooms in TSMC's fabs, the air circulates 90 times a minute. So it's like ridiculous levels of purity, right?
Yeah.
Now, of course, it's very expensive. So when you are seeing a project plan that this is how much the clean room will cost, both sides are guessing, because the company has guessed and you are also guessing whether that is correct or not. And the fact that no one in India has done clean room assembly, and so they will have to get foreign suppliers. So people say, okay, it'll cost more. Sounds like a reasonable, but how much more? We don't know. So if there is evidence of gold plating and it gets discovered 3 years later, someone's neck will be caught. So how do you do benchmarking? So as we started developing these frameworks that look, we want capex benchmarks. How is your equipment? And if your capex is too high, you will not be competitive. It's a capital intensive industry.
Yeah.
Then we also wanted manufacturing cost benchmarks, because remember that today China is massively investing in semiconductors. Already in a certain type of semiconductors, which are called compound semiconductors. So just like, so semiconductors is like, you have a silicon wafer and you dope it with nitrogen and phosphorus or whatever. And then, or if you want high voltage and certain types of usage, so you can have a gallium arsenide, silicon carbide. So these are. In 3 years, Chinese fabs, as they've ramped up, have brought down wafer fab cost by 50%. So one American company went bankrupt, one Japanese company's...
because of rise of these Chinese companies.
Yes. So our question was, how are you going to compete? Given that it's in both our interest that you survive, we want to ask the tough questions up front. So, but with Micron, look, there was low risk that the company would run out of money.
Yeah.
Solid American listed company. Second, they would have a market. So we checked with them that, look, you may have dozens of plants globally, but this is going to be our only plant, at least for that time. So how will it be utilized? So they said, look, 70% we do in-house, 30% we outsource. If the DRAM demand or memory demand starts to fall, then we cut the outsourced guys first. So this fab will be fully utilized. So we are assured that it works. And there won't be gold plating. The US listed company, anti-corruption measures and all that. So it was and plus the credibility boost that comes from that Micron is doing it in India. So it was a huge jump for us. And then...
So this project was kind of fast-tracked?
Yeah, but not fast enough for our patients. So we... I think approved it around October 22. And so I'm part of... So ISM, the advisory board, they created 2 groups called the Techno-Financial Advisory Groups. There was a 3-member group for wafer and display fabs, a 2-member group for packaging. So I was part of both because as a supposedly financial expert. And there were technology experts on both. So 2 in TFAG for wafer fab, 1 for packaging. So we approved. And then, of course, there was a whole process of cabinet approval and so on and so forth. So that was happening. Now, in between, because see, remember, Micron is going to bring its own technology. So they needed clarity on how much tax they'll have to pay. It's a classic advanced pricing agreement kind of structure. But there was no framework to sign an APA for a semiconductor company. So it took 9 months. Now, all of us were getting restless because see, memory is a very cyclical industry, even more cyclical than say foundry business in semiconductor. And it was worrying for us that it was taking so long, but apparently it was the fastest an APA was ever
but designed. So where are we with Micron today?
Micron was cleared in May 23.
Abhi plant is being manufactured?
Yeah, plant has been set up. I think their test batches are out. I think mass production should start.
So this is the very first production outcome from
the first production is actually CG Power. So that has already happened. So the first chip coming out was CG Power and Renesas.
Which kind of chip is that?
It's a logic chip.
Same 40 nanometer?
No, that is packaging. So wafer fab, we only have 1 plant so far.
This is the one in Assam which Tata is doing.
That is the packaging plant.
That is also packaging
plant. So there were 6. So there were 6 large projects that were initially approved. Now there are some smaller ones that have also gone through. And now the first budget, that 76,000 crores, is exhausted.
So
now we are waiting for the second.
So this, for me to understand, this 76,000 crores is distributed across what about 10 odd projects?
Yeah, 10 odd. I think 12, 13 projects.
And majority of them are packaging.
Projects. 1 wafer fab and the rest, and a couple of compound semiconductor projects. And so I'll tell you. So the big ones are Tata wafer fab, which is bulk of that 76,000 crores. There is Tata packaging. There is the CG Power and Renesas. And Tata's technology partner in wafer fabs is PSMC, Power Chip Semiconductor. It's the 3rd most important fab in Taiwan.
Understood.
And then we have Keynes Technology. And Micron, and then there was HCL Tech Foxconn.
So, and is there a Semiconductor Mission 2?
Yes, so that's the expectation at the Semicon India this year. So the semiconductor industry is so collaborative, and it needs to be so collaborative because, as I said, there all these blocks need to work together. So Semicon is the conference where all these companies come together. So Semicon India is a new fixture. So earlier there was Semicon West, California, Semicon Taiwan, Semicon China, Semicon Korea, and now there is a Semicon India. So at the Semicon India this year, which the Honorable Prime Minister inaugurated, he effectively said that, look, the second package is almost done. It's going through the files.
So it's safe to assume it's going to be hopefully dramatically more than the outlay.
Dramatically, I don't know. I mean, I am not privy to what the size of the thing is, but yes, I do think that the first one we did not blindly, but we had no idea of how good or bad things would be. Now we have a much better sense. So I can tell you what I would like it to be. So given that whatever projects are approved under this would be coming online 2031-32 at the earliest.
From the Semicon 2?
Semicon 2. Because it will take a while for projects to come through. There are people waiting for it to come through. So I think this time the flow will be much better. But we would like to be in the 7 to 12 nanometer range because by 2032, I think that will be the mass production
Okay.
nodes, but we'll see how it happens. Closing that argument on that story on clean rooms. Whereas we initially assumed that clean rooms in India will be more expensive than those elsewhere. What was fascinating was that there's this company called Yes Technologies, which provides packaging equipment for Micron. So they have this plant in Coimbatore. And they were so excited that, look, when we set up our clean room in Coimbatore, of course, it's class 10,000, so it's not that cutting edge, but it's still pretty complicated. He said it's a fifth of the cost of our clean room in Arizona.
Right.
And as you know, Arizona is the new chip manufacturing hub that is getting constructed. And they said that, look, when we told Micron that, look, if this guy and all local suppliers. So as we start getting into this, you will find lots of positives as well. So there are lots of unknown problems. As I said, the customs guys don't know how to classify the equipment and all of that, or that the soil in Dholera is too sandy, and therefore establishing that platform turned out to be more complicated. So there are things that you will discover.
But is semiconductor continues to be like big industry play, or the scope for new age players as well?
The crop of companies that are large has been changing. I think 80s and 90s, the Japanese were very important. I think then they slowly started fading out. The Taiwanese became much more important. Then now, in terms of wafers produced per month, China's share is going up dramatically. So there are always new companies that come in. There are also new challenges that come at every node. So, for example, Intel struggled because they couldn't get extreme ultraviolet lithography. There will be new challenges. So, as one of the equipment companies was showing me, and I got it validated. I mean, I read it somewhere else as well, that till 15 years back, Mendeleev's periodic table. So, there were 15 of those elements that were being used in a cutting edge chip about 15, 20 years back. Today, there are more than 50 elements.
50 out of roughly 100 known elements, 50 are used in a chip.
Yeah, and many of those, if you remember, are artificially. I mean, they just created it for like few seconds in some lab. So it is remarkable how So what has happened now is that 1 nanometer is like 10 angstrom. The moment you go to 5 angstrom, 6 angstrom, 3 angstrom, you're talking about like moving atoms around. You can't make transistors smaller than that.
And 1 angstrom is roughly the diameter of an atom.
Exactly. So you can't go smaller than that. So now new types like 3D semiconductor, 3D transistors, different types of integration. So different types of packaging, how to get the same Moore's law type of productivity gains and reducing power consumption. So all of those things will create new technological challenges. Whoever solves them first will, of course, be able to progress.
Got it. So the story that at least I'm able to understand is because of these 9-10 projects which got off the ground because of Semiconductor Mission 1, and these are all getting into production soon. Semicon 2 is going to come hopefully soon, and we can be little more ambitious with that. So in some ways, the foundation stone for the semiconductor ecosystem is being laid in this decade.
So our objective, as I've heard from the policymakers, is to get 12 to 15 large sized. So of the 12, 13 we've done, I think 4, 5 are very small. I mean, they're just there because they've been doing semis. See, there are companies in India which have been operating since the 60s and 70s. They've just not grown in size. So there are some small ones as well. So we want to get 12 to 15 large projects on the ground, and then the government can pull its hand away and then let the ecosystem flourish. So for example, if you're setting up a wafer fab and something breaks down, remember that some of these fabs, some of these chips have 200, 300 layers of sort of stacking material. They take 4 months to process, 5 months to process. Now imagine if something breaks down in between. The risk is that a lot of the lots will have to be discarded if you have to wait for too long. Now, how quickly can the engineer come? Now, the engineer may not be close by. I mean, they have to take a visa and then come down. And it doesn't make sense for an equipment company to have an engineer located if there are no fabs. So these are the starting points, and which is why I think the first fabs required a lot of capital subsidy because initially projects will get delayed, and that means a cash burn. So in a way, if you think about the way discounted cash flows work, because these are very capital intensive industries. So even if your return on capital employed is negative, meaning that you're burning cash in the first couple of years, given the amount of cash that has been handed over to you. And what we made sure is that in the first batch, the large projects, they are all backed by solid balance sheet. So I must have been hated by everyone for insisting there's not going to be any debt. That, because companies fail when they take on debt and then they're not able to repay the interest. But that's when the bankruptcy and the banks start come calling. If you put your own cash, then you will destroy wealth, but you will not go bankrupt for a long time. So we made sure that these firms can survive for 8-10 years. And in those 8-10 years, these are all solid entrepreneurs who are investing for the long term. They'll figure their way out. So we are kind of backing the teams to do it on their own. So if you have 12 to 15 large plants operating in India, then there will be technicians, engineers, innovator ecosystems. And what will also start happening is that the likelihood of large chip design firms coming up. See, India has 1/5 of the world's chip design engineers. So out of 1.5 million chip design engineers in the world, 300,000 are in India.
But how many chip design firms in India?
I'm sure there are a handful now, but no one of size. Zero, effectively.
So effectively, this 20% of chip designers in India, they're all basically working for multinationals.
Yes.
And
so Intel, for example, apparently has 30,000 people working in India for them.
And today, what is the barrier to entry for a let's say really ambitious entrepreneur to start a chip design company?
Very excellent question. And this is where when I was talking about disruption, or what do you use to enter and how the industry changes. So think about chip designing as like how, say, I'm sure Arnav played with these circuit design things, like you're placing things and connecting them and all that. Some of these chips today have billions of transistors. So imagine, of course, there are libraries that help you do that. It's not like everyone writes C code, right? So there are libraries, but you have to place those things. And to do a reasonably sophisticated job, the cost of a chip we used to be, because it takes a long time to design it, and then tape out, meaning that converting it into something that earlier, like 1960s, people used to draw circuits, shrink them through photographic things, and then print them like you print and all that. But today, of course, you can't do all of that. So it has to be, chip design has to be translated into something the fab can understand, the fab machines can understand. So this is all very expensive. The EDA tools are very expensive. The license to those, the amount of processing you need to just make sure that, imagine like rendering a video. You can say that what Mukesh and I used to do, the man picks the flower and gives it to the woman. It's easy to write in English.
Mukesh and you used to do?
Yeah. That's why a BTech project.
Pick the flower. Okay, fine.
No.
All right.
we tried.
I don't know, man. What was your BTech project?
No.
Good for you. If that you got away with that.
No. So I did the English parsing and Mukesh did the graphics behind that. So rendering it used to take a long time because the computer needs the bits to be there.
Yeah.
The compute needed is a lot. Storage needed is a very expensive proposition. So what used to cost $10-20 million now costs several $100 million.
Are you trying to discourage people from starting a chip design company?
No, but hold on. So this is where the fun thing happens. So I recently met a team of people who think that what can globally be done with $250 million will be done at $100 million in India.
Because where is the arbitrage?
Yeah. So one, you get very cheap engineers in India. Two, what is also happening, and this is where the geopolitical shift is so fascinating. See, many of the American companies who have been barred from entering China have lost a lot of money.
Yeah.
Or lost a lot of potential revenue.
Sure.
So it has also hurt their ability to do research.
Yeah.
Because see, all of these are very technology heavy, very, very IP intensive companies. So the R&D to sales ratios are very high. Suppose you lose $10 billion of revenue. You lost $1.5 billion of R&D revenue. What they're even more worried about is that in their absence, the Chinese EDA companies and the Chinese equipment companies will start sprouting up. And then 5 years later, start hitting them. So they have to create an ecosystem which they are funding because their customer survival is very important for them.
Yeah.
So what they are saying is that, look guys, if you're in India, till the time that you're generating revenue, I'll give you massive discount on your licensing.
Sure. Understood.
Right. So these are things that are starting to happen. This is the ecosystem disruption that India can take advantage of. Same with equipment companies. Equipment companies had a huge business in China. Now, because of geopolitical reasons, they've been barred. And they realized that Chinese equipment companies in 5 years' time, just like they're beating the stuffing out of everyone in shipbuilding, in cranes, in heavy equipment machinery, electric vehicles and all of that. They will start doing the same in semiconductor capital.
But look, 100 million is also not easy for a startup. So what is that? Just if you have to paint a picture of, let's say, some of these.
100 million is a critical chip which will be globally competitive.
Understood. So let's say I am a very competitive chip designer in one of these multinationals in India. Me and a group of my friends, we want to start a chip design company. Where do we start, and what is the role of Semiconductor Mission in facilitating that?
So remember that your eventual cost may be $50 to $100 million.
Right.
If you want to do a reasonably size or address a reasonable size TAM, see, if you want to do a microcontroller which goes into, say, refrigerators and washing machines, and there's a captive Indian market, you can actually sit with the equipment company or the OEM and do a custom design. These are called ASICs, application specific integrated circuit. So you can do that. You can, I think a couple of $1 million, you can design a chip.
Yeah.
If you want to target a larger applicable, like what you keep talking about in your book, that your TAM has to be big.
Yeah.
So then you're talking about something which is designed at a 3 nanometer, 5 nanometer level at least, and then targets like, say, mobile phone system on chip or some of the big ones. And those you need $50 to $100 million, but you don't need all that upfront. So what you can do is, and this is where the DLI scheme, the Design Linked Incentive Scheme, the government, today I think that amount is not large enough, but our hope is that in the second scheme, that quantum, newspapers are saying it will be 10x what it was there in the first. So 1,000 crores will become 10,000 crores. There are also, like Ministry of Telecom, also has a 250 crore competition to design chips that go into telecom equipment. So there are many such things that are starting off.
So look, design competency and incentive is one part. What about the, going back to TAM, the generating demand? Is that also for an upstart chip design company to just generate enough demand for what they're going to build? I'm assuming it's going to be a sizable challenge.
It is. So, and this is part of the reason why we didn't have startups, right? So, what do you design chips for? So, you need to have some visibility of what's coming 3-4 years later. Because it'll take you 1-2 years to design, do the test chips, test batches, then try to integrate it with the final device, which is made by someone else. And then rectify and then do mass production. Right? So, you need to know what this phone company is going to launch in 3 years or 4 years. How do you do that sitting in India? So, that was I think the key bottleneck. So, this is where I was a big supporter of the PLI schemes for mobile assembly. That once you have the assembly and basically some visibility in the ecosystem of what devices are coming, then some entrepreneurs will then start working. You get some visibility. You start designing stuff.
And are you seeing are people starting this? That's happening?
Oh yeah, very exciting. See, I'm part of the TFAG, and so of course when the proposals have gone through a certain level of checking, then they come to us and clearance. But when I go to Semicon India, I get to see all these entrepreneurs. There's some very fascinating ventures that are coming up. But remember that very few of them will succeed. So I remember showing this chart back in 2022 that for one DRAM controller chip, which was worth $30-40 billion coming out of China, there were 110 of them which had started. So you need to have that large cohort. So I hear of some very talented engineers, many of them, and this is again where you sense that things are starting to fall in place. Of course, fingers crossed. There's 20 years of hard work, right? Remember that we are kind of where the Chinese were 25 years back. So there's a long distance for us to cover, and we have to be patient. But at the same time, you realize that many of the engineers who left India 20-25 years back are now in their late 40s, early 50s, and their parents are now mid 70s, late 70s, and India is very different from when they left it. So quality of housing, quality of cars, quality of schooling, and pay packages, and of course, so they want to come back to India as well. So they're just looking for opportunities. So in fact, one of the people who I think will be potentially applying in the second round, he said, we can set up a much larger project. And I said, but where will you find the engineers? He said, there's like a flood of engineers just waiting for projects to come up in it. So I think the talent in the Indian diaspora, even in India. In fact, when I asked this equipment company, the packaging equipment, memory packaging equipment company, did you have trouble finding skilled people? All there.
And in this, as the semiconductor ecosystem develops in India, where does the semiconductor missions, how is it thinking about the equivalence of GPUs, etc.? Because that's where everyone has been watching and sick of where NVIDIA stock is. The alternative, perhaps Google's TPUs emerging as a one competitor, but again, probably only two companies in the world. And I think last 24 months it's become clear that AI is going to be extremely integral to pretty much anything that happens in our world, and all the AI is going to be running on GPUs. So to what extent, or is going to be third, fourth phase of evolution? Is too early
So
for
see,
something about
I think there are so we should aspire to get there.
Yeah.
I'm aware of design companies in India which are in 28, 29 going to tape out chips which will take on NVIDIA. So obviously, I mean, so you need entrepreneurs, there are VCs who are willing to back them.
Yeah.
Not sure they'll succeed. I hope they do. There's
And
also
many such attempts in India?
I mean, okay, not even 5% of the ones of what is happening in China or the US, but clearly way ahead of what we would have dreamt of 3 years back. So this is where I'd like to summarize where we are in this, right? So I think in the last 3 years we covered a long distance. I think what I see is the quality of proposals coming to us. Just in terms of the seniority, the seriousness, the large groups, large balance sheets that are backing them, the technology partners that they've managed to get, the ambition of where they want to take the business, all of them are several notches higher than where we were in 2022. The maturity of India's Semiconductor Mission in terms of all the questions that we used to ask. So this is where learning curves exist, right? Humans are very fast and they're very smart people. So all the questions that we would ask in TFAG meetings in the first time the reports came to us are already asked before they come to us. So now the decision making is much more strategic. We've also, I think, managed to get some excellent experts. So as you can imagine, as the government's own network expands, figure out people who are willing to contribute their time. Remember, it's a thankless job, meaning that you're sticking or you're signing off on things where if things go wrong, your reputation is at risk. And of course, there is no reward other than the happiness that the industry is getting developed. But there are people who are willing to do that. Some super experts that we have on the technology side now. So we've come a long way, but at the same time, we need to stay at it for 20 years. We need the government funding to keep flowing. So we need to build our credibility. A number of large Indian groups initially, when they were approached by the government that why don't you, they had zero trust in the government. Some of them said that, look, you're talking about hundreds of millions of dollars or maybe thousands of crores. Do you know that to get 50 crores of payment out of the government, how many pillar to post runs I have to do? And so how can we be sure? So making sure that we build credibility, that subsidy checks, which are pari passu, basically the entrepreneur puts in X amount, state and central government put in Y amount. All that happens on time. Credibility builds. People start saying, oh, you know what, the rest of the government may be what it is. ISM works very differently. India is very serious. Every time Semicon India happens, the leaders of global semiconductor companies who come to India actually are hosted by the Honorable Prime Minister himself. He takes notes, comments on all the things that are mentioned as issues. So as of now, the desire and the momentum, I think, is super strong.
And given where also, Neelkanth, we are on the geopolitics of the globe, seems like there is no choice. This in some way has to work. I think there is no version of economy where you don't have at least some sense of self-reliance and also competence in-house to be able to exist as a free, independent nation in the world, right? So in some ways, whole country needs to root for Semiconductor Mission, and its objectives to come true, irrespective of political parties and
exactly
the government.
And the whole ecosystem. So, and this is what I was trying to say earlier, that look, the value add is in supplying gases, supplying clean water, because even the layers of photoresist and insulator and metal that you put, and then you have to clean it up. The chemicals need for cleaning, they need to be extremely high purity. Water, there's so many other suppliers that emerge. There is so much value add in the ecosystem. That is one. Two, once you have that expertise can be deployed in several other industries. So it is also a part of just technical training at a giant scale. At the same time, as much as I think we should try to maximize the value add we can have in India, this is one sector where one shouldn't even try to be completely Aatmanirbhar. Because, the reason why this industry is done so well, it is that Moore's law has progressed so nicely. is that, so of these 50, 70 blocks that I said, that everything, there is an oligopoly. So that oligopoly is not uniformly distributed geographically. So you need to have, the memory companies in Japan and Korea and GPUs in US, designed in US and fabbed in Taiwan.
So somewhere in this 50-60 center of expertise, India needs to also carve its place and exist and be part of those oligopolies somewhere.
Correct. So right now, I think we've backed some excellent entrepreneurs with substantial amounts of capital. The hope is that in 5, 7, 10 years, so remember that when TSMC started, and these are things that are much more detailed and much more colorfully described, and to repeat all that, one industry move that Morris Chang took advantage of, or TSMC took advantage of, was the separation of IDMs into fabless and foundry. So they were independent device manufacturers. So basically the same company did design and manufacturing. And he figured that it was starting to get so complicated. Some companies would have to focus on manufacturing and some companies would have to focus on design. And he said, you know what, we are only going to do manufacturing. We are not going to compete with design companies, and therefore they can trust us. And we will collaborate intensively with the cutting edge design companies. And that is how they have out-competed. So I remember when I was in Taiwan, UMC and TSMC were considered competitors. TSMC had started to establish. But the fact that UMC will be a $40-50 billion company, which is a lot, but TSMC is in trillions, we wouldn't have imagined that. So it is possible through consistent innovation, consistent quality, consistent focus on research, making big bets. So Morris Chang coming back from retirement in 2009-10 and that famous deal with Apple, those were strategic bets that played out phenomenally well for them. I'm sure if you are part of the game, as of now we are not even part of the game. Once you are part of the game, you will start seeing those opportunities.
Right. So good news is because of effort of Semiconductor Mission, there is now at least hope and there's something happening on ground. The real plants are being set up. And so I guess I can, maybe on the closing note, I'll just say that people who are interested in the deep tech ecosystem of India should very closely watch what happens with this first set of companies, as well as what's going to come in ISM2, and perhaps attend also this Semicon India, which happens last
once a year. So September.
So that's probably become a big event on the semiconductor industry calendar.
So this time the the stalls, there was a lot of attention.
I'm almost tempted to kind of go into totally different segment of let's walk through exactly how a chip is manufactured, soup to nuts, but we'll park that for a separate episode later, Neelkanth. So thanks so much for giving us a full overview of where we are with the whole ISM story. Thank you. At SparX, we aim to bring to you stories of exponential impact. We share in-depth analysis of what goes behind success stories. If you find our conversations interesting, you can join us by subscribing to our YouTube channel. You can also listen to SparX on Spotify, Apple Podcast, or any other audio platform of your choice. If you have any suggestions on who we should invite or what topics we need to cover, just let us know in the comments. We are always listening, looking for ways to improve, and keep getting better as we go along.